Hi everyone. Today we are going to see about step-up chopper. It is also called as boost converter, which means the output voltage is greater than input voltage. This is one type of a DC to DC converter. That is, we are converting the fixed DC into a variable DC. Basically, a DC-DC converter is an electronic circuit comprising of electronic components like inductor, diode, capacitors, and any one of the power electronic switches. In this diagram, the power electronic switch shown is IGBT. We can use BJT or thyristors also. I already noted that the purpose of DC to DC converter is to convert the fixed DC voltage to a variable DC voltage. Here the boost converter will give the output will much higher than that of input voltage. We will see the step by step operation of this converter. There is two conditions. First condition is that switch is turned on and the switch is turned off. The switch is here noted as IGBT. See the circuit diagram, that is figure 24 and 25. Here the switch is turned on. Switch is turned on means the supply, that is the input supply we are giving, is passed through the inductor and the switch, and it closes to the negative. So this forms a closed loop. The another loop forms like the capacitor to the output voltage, which means the inductor will get charges and the output will be supplied by the capacitor. The diode, which will not conduct during this mode of operation. When the switch is turned off, here the switch is turned off means the circuit will, that is the circuit voltage, that is the current will passes through the inductor, the diode, and to the load, and also to the capacitor, which means the input voltage, the inductor will start discharging here in the same direction. That is, the inductor will never opposes the sudden change in current direction. So the inductor will discharge the current in the the energy in the same direction. So the supply voltage and as well as the inductor voltage will be added. So the output voltage will be higher when compared to the input voltage. In the meantime, the capacitor will get charges. What it will, how much of energy it loses in the mode 1 of operation. Here the waveform of the boost converter. The first thing shows the drive of the switch, that is IGBT. We are giving that is a turn on shows the positive triggering, and sometimes the turn off shows that the value will be in 0. In the meantime, when turned on, there will be no output voltage, that is no boost voltage that we are measuring. The capacitor voltage will appear across the output voltage. When the switch is turned off, the output voltage will appear across the output terminal. In the meantime, the third axis shows that current through the inductor, that is I minimum and I maximum, that is minimum current and maximum current. The inductor will get charges up to the maximum current. When the switch is turned off, the inductor will start discharging. This is a continuous current, depends upon the inductor value. And the next thing is output DC voltage, the next axis, and the next one is output current. Here based on the operation of, that is mode 1 and mode 2 operation, the equivalent circuit shows with comparison with the graph. Here the output voltage equation is also derived. First we have taken that VL, that is inductor voltage with respect to time. Inductor voltage with respect to time shows that 1 by t, 0 to t, VL of t into dt. So VL is equal to 1 by t, 0 to t, 0 to t, L into d, IL of t by dt into dt. So the dt and dt will get cancelled. So the L is a constant value, that is inductor is constant. So L by t, 0 to t, dIL of dt. At t is equal to 0, that is lower limit, IL of t is equal to I minimum. at t is equal to t, that is upper limit IL of t is equal to I minimum, that is we are taking it for an one full cycle. At 0, the next thing is pi, so 0 del t t. So we can see that when it is 0, that is I minimum, when it is t, it is also I minimum. So the inductor VL will get as 0. Then the average voltage, that is VAB. VAB is nothing but the voltage appear across the switch. That is what switch we are using. Here the two different switches are shown. One is IGBT, the another one is transistor. So VAB is equal to 1 by T, 0 to T, VAB of T into dt. So the equation shows that VAB is nothing but which is equal to that of output average voltage. So we can take it as VAB is equal to 1 by T del T to T V0 into V0 average into dt. So we can get V0 average into 1 minus del. We are adding the closed loop equation, that is inductor voltage and the voltage appear across the transistor, will get V0 is equal to Vs by 1 minus del. This equation will gives the output voltage, the numerical output value of the DC to DC converter. The input voltage is nothing but Vs, and the del is the duty cycle, that is what firing angle and what time we are turning on that particular switches, and V0 average is the output voltage appear across the load. This is the operation and output voltage equation of boost converter. Thank you.